Good morning, everyone. It's April the 15th on a lovely sunny day in Oxford. We're going to talk a little bit about your internal assessment. By now, you will have read in your textbook from page 660 onwards about the assessment criteria. We'll talk about them very briefly. Then we're going to look at some practice examples to get you in the frame of mind of understanding the criteria. We're going to look at some examples from probability. So the first criteria is communication. And basically, your target audience is people your age. So your friend, your sister, your brother should be able to read your work and understand it. It needs to be organized with an introduction, analysis, conclusion, reflection, have an ending, and it needs to be coherent. That means there has to be links between the different sections so that the reader doesn't feel there's a big jump of something unexplained. It needs to use good mathematical presentation, the correct symbols, the correct graphs. Things have to be labelled, axes have to be labelled. For example, if your internal assessment was about trigonometry, of course you'd present your work with some diagrams of triangles. I should have also mentioned communication. You would define any terms that might not be mathematical. For example, if your internal assessment was about a mathematical aspect of economics, you need to define the economics terms so that we all understand. Mathematical presentation is about the mathematical terms that you use and how well you use them. And sometimes software is very useful here in generating graphs, diagrams, GeoGebra, Excel, things like that. Personal engagement. You get a mark for how well engaged you are in your work. And this means it's a good idea to start off with something you're really interested in, really passionate about. The best maths, the most enjoyable maths is when you're really engaged in it. Think of an architect or an engineer or a designer. They're really engaged in what they're doing because they're making it. If you choose something you're really interested in, you'll be making the maths, you'll be in control, you'll be engaged. If you're asking questions like, what if I do this? How does this work? Or if you're presenting ideas in your own way, that's one way to be sure you're engaged. Reflection, looking backwards at what you've done. How strong were your conclusions? Can you be critical? Can you show critical reflection on your methods or your findings, the strengths and weaknesses? In a way, personal engagement is looking forward. What if I do this? How does this work? And reflection is looking backwards. But try to be critical. Don't just say I should have used much more data, for example. And finally, use of mathematics. Demonstrating that you understand the maths. If you're doing probability and you use the multiplication rule of probability, is it for dependent events or independent events? Why? Can you demonstrate that you understand why you're using the rule that you're using? All these will become more clear as the weeks unfold. Again, you need to read the pages in the book, page 660 onwards. Okay, we're going to have a little tour around my website. It's written for the IB, but I started to write it 15 years ago. I was very engaged in what I was doing, partly because my kids were very young and I wasn't getting much sleep. It was actually really relaxing to make this and become engaged in it. And because I made it 15 years ago, there's some things I've forgotten that I even did. So we're going to have a little tour to maybe give you some ideas for an internal assessment practice. If we start off here with random behavior, for example, we've already done some of these very quickly. All the pages on the website have an icon like this, and if you right click, save link as, it will download the spreadsheet. This particular spreadsheet gives you the real data from the United States 1978 about the frequency of each birthday, and you'll find it's kind of, oops, it's kind of surprising. It's the blue graph here. On the y-axis we have the date in February 1978. On the y-axis, on the x-axis, on the y-axis we have the frequency. You may have thought it would be a constant level, but it has a repeating pattern, and that's something to explore in other months. But my purpose today is for you to just be aware that that is there, and maybe if you're interested, go and investigate. Random binomials could be an internal assessment starter. Benford's law is quite a recent discovery in maths. It's used for detecting fraud in financing and accountancy. If I go here, the world of probability is full of paradoxes and counterintuitive results. Simpson's paradox is one such result. We've already seen the Chevalier de Mer example. I've shown that one to you. We've done that. And we've also done Chevalier de Mer 2. We've talked about that. We haven't talked about the Dice World Cup finals. I use that every 4 years when it's the World Cup. We have looked at the non-transitive dice, however, and the spreadsheet is a bit like that. If I just download it there. Where we imagine it's the semi-finals of the World Cup between dice A, B, C, D. If I press F9, yes, I get another trial. So if the semi-finals are dice A versus dice B and dice C versus dice D, which dice is more likely to win the World Cup? Now, the birthday problem is a very famous problem, and there's a word of caution here. Because of the internet, some problems that were not so well known 30 years ago are now very well known. The birthday problem, you'll find many websites about the birthday problem, and the problem for you as a student is you could use the birthday problem as a starter for internal assessment, but how do you make sure the work is your own, that you have full ownership, and that you are fully engaged? That's something to think about. The concept behind the birthday problem could be adapted, for sure. It's known as the pigeonhole principle. And basically, to cut a long story short, if we had 32 people invited to a party, if I reset this. Yeah. Mm. Oh yeah, it works. What I've programmed here is 32 random birthdays in the calendar. The pink squares are when at least 2 people share that birthday. And you can see that more often than not, there are at least 2 people who share a birthday if we have 32 people. Most people think you'd need 180 or something people. You don't need that many. In fact, you'll find the smallest number you need is, come on, is 23. Very counterintuitive. So every time you watch a football match in which there are 22 players on the park plus 1 referee, okay, plus 2 linesmen, that's 25. The probability that at least 2 of them share birthday is around about 50%. And there's another birthday problem, which is similar. There's Monty Hall. I'm not going to do that right now. It's a very famous problem. Again, you would have to adapt that for your own, to make it your own. Conditional probability is another one where you can construct Venn diagrams to make events which are not mutually exclusive, but they are statistically independent. Just 2 more. Samuel Pepys, the English diarist, and Sir Isaac Newton debated this dilemma. And again, there's a spreadsheet here which investigates it, about a gambling contest. Remember, we already saw a gambling contest with the Chevalier de Mar. This one here is a really difficult one. I've no idea what the answer is, although it starts off with something easy. It's based on a dice game. This one is based on Sisherman dice, which are different to the non-transitive dice. Probability in the real world. Some of these links don't work anymore. But this one here, the Smart Luck company, the last time I looked at it, it's a company which designs software to help you win lottery jackpots. If we go back to the home page, oh, and this one relates to Rui's extended essay, where she's looking at this weird distorted dice. And this, no, not that one, this one. This is really actually written for math studies, this one, but we can adapt it a little bit for our purposes. Your internal assessment must have good communication and use the right terminology and something you're engaged with, and using the correct presentation. Okay, like a box and whisker diagram is a good example. And reflection. If you read this example, it has all those things, and your task is to choose one idea from my website, planetqhe.com, and investigate it, write up your findings, and give it to me next week in such a way that it addresses the criteria. And gives you something interesting and stimulating to explore. And we'll use that as a rehearsal for the real internal assessment. So I will look at your work in relation to the criteria and give you a grade. Okay, that was supposed to be 10 minutes, it's 15, so I'm signing off now.